All right, ladies and gentlemen, welcome back, welcome back. I love the energy. If we could please continue that into our lesson today. Today would be an A day, which is very nice that we have, right? A, B, C, D, E, with A being Monday and then E being Friday. However, next week that gets a little altered because if you've looked at the calendar, we have a 5-day week this week. It's always hard to come back to after a holiday break, but then we have 4 days, 2 weeks in a row. Yeah. So next Friday, you begin what is a 4-day weekend for you. So how nice. Okay. So just to give an overview, where are we heading today? All right. Well, today we have a double period. We will be working one period with a lab activity that will really help to bring to life percent composition. We also need to review chemical naming. I am not expecting us to remember crystal clear everything we learned before break. So we need to do a refresher and then just practice when we're given all the different types of formulas. How do we name them? So if given a formula, how do we deliver the correct name every time? Tomorrow we'll go the opposite direction. If you're given the name, can you get the correct formula every time? Wednesday, we will be in lab doing a very classic decomposition reaction. Thursday, do some practice because on Friday, I told you at the end of the first week, which it is on Friday, the true end, we will test ourselves on going both directions. If you're given the formula, creating the correct name, and if you're given the name, creating the correct formula. We'll just quiz on that on Friday. That'll take about half of our time. Then we'll begin the new kind of formula analysis understanding, bringing back moles and grams and all that great stuff. The 9 weeks ends next Thursday. So this is a great chapter that's pretty deep and wide. I want to definitely kind of force us to really get good at naming and formula writing through a quiz on Friday. That will also be tested next Wednesday. So after you prepared for that, those will just be more points that you're earning. And I want to have some kind of conclusion to this work before the end of the 9 weeks. But we need to do more lab work to really be finished with this content. So we'll have an assessment next Wednesday. It's kind of 75% of the chapter, if you will. Then continue lab work and then do a little assessment with our lab work. So that'll be the plan. Okay, so this is where we're going the next couple of weeks. Right, 2022. I love that picture that I found. I don't know, I don't necessarily like sit down and write goals or force my kids to have goals. I know some families do that for the turn of the new year or ask about New Year's resolutions. But this year I just said to my children and my husband, so if there's one word that you want to kind of have as your goal or like your go-to term for this year, and it was just funny. My daughter's so funny, and she was like coming up with just things that would make us laugh. And then my now 17-year-old said the perfect term. So we were trying to come up with all these inspirational little terms, but then my 17-year-old said, better. That's just what, and I think that was so perfect, just better. And whatever way you can really embody that. I don't know, Caitlin, were you super, super excited to come back to school today? So not terrible, but not like, woo, couldn't sleep, because you were so excited. All right, let's see, Avi, how excited? Scale of 1 to 10, 10, you can't sleep because you're so excited. 0, really? At least it's not negative. At least not negative. Well, ladies and gentlemen, just because I knew I was going to see you guys, that's what got me to get out of bed this morning. You were such a gift, and I thank you so much. All right, so periodic table. If you need a polyatomic ion sheet, you know you can get extra copies if you would like. Can we, in our handy dandy packet, okay. Remember, we talked about the different kinds of chemical naming. So, can we turn to page 16? 16, please. It looks like this. Okay, again, if you need a fresh periodic table, polyatomic ion sheet, you know where to find them. And we're looking at page 16. All right. My best advice for us as a quick refresher is when we are going to name a chemical formula, we look at the first element, barium. And we ask ourselves, all right, what kind of compound is this, knowing it starts with barium? Okay, Maddie, barium, metal, non-metal, hydrogen. All right, then if it begins with a metal, what kind of compound is it? Ionic? Is it covalent? Is it an acid? Ionic. Every day, all day, it's going to be ionic. So then the next question is, okay, do we need to show the charge or not in the name? And Maddie, how do we know that? Oh, are you sure? No worries, because we need a refresher on this. Okay, we ask ourselves, okay, where is that metal found? Is that a metal that shows the same cation charge all the time? Max, barium, second group. Do we trust its charge every time when it becomes an ion? Do we know its charge?
Yes.
Yeah. What will it be?
+2.
You got it. If it were a member, Max, of group 1, what would it be?
+1.
Yep. If it were a member of column 13, aluminum and gallium, what would it be?
+3.
Yeah. And then remember, silver, zinc, and cadmium, kind of sneaky, +1, +2, +2. All the other metals, we have to show their charge. Okay, so barium, we know its charge. So we just dig right in and name this. Remember, compounds are composed of cations and anions. We're going to name the cation and then include the name of the anion. So this will just be barium. No need to show its charge. Okay, Troy, is the anion a polyatomic ion? No, this anion is simply monoatomic. It's a single element that's our negative. So, do we just call it chlorine?
Chloride.
Yeah, why do we call it chloride, sir?
Because it's the ion form.
Excellent. We drop the ending and replace with "ide." So that's just barium chloride. Absolutely fantastic. Absolutely fantastic. All right. So Anna, number 4. Number 4 also begins with a metal. Also begins with a metal. Okay. So then we know, oh, it's ionic. Do we trust its charge? No. Okay. So now is when we go into the formula. Okay. Let's see. Megan, copper. Is copper paired with a polyatomic ion or a monoatomic anion? You got it. Do you remember what SO4 is? Perfect. Sulfate. Sulfate. Ty, what is the charge of sulfate? You got it. How many sulfates do we have in this formula, Ty? Yeah. So compounds are neutral. If I have 1, -2, and we have 1 copper, so what is the charge of copper here, sir? You got it. So this is copper 2, and then this simply would be sulfate. We learned the name because that is its name, sulfate. Good? Yes. What do you think? Yeah, absolutely. And why? Noah? Why do we need to include that too? Are there? The charge. Okay, Roman numerals always with chemistry means the charge. Always. Promise, promise, promise. Always. Okay. And it's a metal that can show a variation of cation charges. So we need to say which one it is. Okay. Promise. Yes.
For the first one, since there's a like 2 chlorine, would it be dichloride or no?
So glad. And Elena, thank you for reminding us that we saw the addition of prefixes, but that's if it's a covalent compound.
Okay.
Now, how do we know if it's covalent?
If there's 2 non.
Perfect. And truly, we can tell by the first element, because if we have a metal, metals always are cations, they're going to come first. So can you look here, Elena, and can you choose a number of a formula that is covalent?
2.
Excellent. Excellent. All right. Whenever it begins with a non-metal, we don't have to do anything with charges. We just apply prefixes to reflect the subscripts. But remember, we don't use mono with the cation. That's really silly. So phosphorus, dye, and Elena, do you mind finishing it? Perfect. Thank you. Excellent. Yes, sir.
So for copper,
Uh-huh.
so if it was +3, then would you do 3? And
You
So then-
certainly would.
why are you doing like -2 with SO4?
Okay. I need to determine what charge copper is showing in this formula. And I know that a formula is neutral. And the way that it's neutral, it's made of positive and negative things. I know my total positive has to equal my total negative to deliver a neutral compound. So to determine how positive each copper is, I need to look at what it's paired with. So we're kind of working backwards. If I asked you to make a formula of, let's say, copper, now the other common charge is +1 and sulfate. If I asked you to create that formula, well, copper, if it's showing a +1, and I know sulfate collectively is -2. Well, if I just have one of each, that won't give a neutral compound. So let's call them multiple 2. So I'll need 2 coppers. Yeah. If it were 3, what would your formula be?
So C +6 and then SO4 -6.
How do we get copper to deliver a positive 6 total?
times it by 2.
Yeah.
So then you would put that. That makes sense.
Where do I show the 2?
In the parentheses, you would show the 2. I don't know.
The parentheses show charge. Okay. Here, copper is delivering a positive 3. So if I was going to name this, I would put Roman numeral 3, but that shows charge. Right? Just trying to get the correct formula. If copper is showing a positive 3 and sulfate is a -2, lowest common multiple is 6. So for copper to deliver a positive 6, you said multiply it by 2, or I need 2 of them. I show that with a subscript, yeah? How do I get sulfate to deliver a -6?
You would times it by 3.
You got it. And if we need more than one polyatomic ion, it's in parentheses with the subscript outside the parentheses, yeah? And then the way I would name this is copper 3 sulfate, okay? The prefixes, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. You have those written in your notes. All right. So then acids. So if it begins with a metal, we have to ask, is it main group, transition? If it is, you show the charge as Roman numeral. If it's non-metal that it starts with, then I always put my markers down. We are going to apply prefixes. It's supposed to be arrows, sorry. If it begins with hydrogen, then you know. And remember, we talked about 2 different kinds of acids, binary or oxy. So this was the new stuff that we talked about that we really need to practice today. All right. Of these, which one is a binary acid? Tell us what led you to that selection. Yeah, perfect. And binary, you're absolutely correct.
Well, I don't think it's right, but I kind of forgot, so I just guessed because there's no, like it's just H and F, there's no numbers below it.
Not bad at all, but it's not the subscripts. And Abby, I must say, I don't think you make blind guesses. I think you make educated guesses. Yeah, I'm not expecting us to remember crystal clear, for crying out loud. So bravo, bravo. But that, for example, 8 is a binary acid, 9 is an oxy acid, 3 is an oxy acid. Caitlin.
It's because it's hydrogen plus just an element.
Perfect. Just one other element. Now you can have like H2S, but you're looking at only one hydrogen, like 2 element total. It doesn't mean that you won't have more than one.
Okay.
Yeah. So the binary is referring to the number 2 elements. Wonderful, wonderful. Now, the simpler acid has more to its name. Remember, there's 3 parts. The prefix of hydro, the ending of ic on your anion. So this will be hydro. And so go ahead, Noah. Excellent. Okay, so the 3 parts, prefix of hydro, the ending of ic on your nonmetal, and then the word acid. So if it was H2S. All right, go ahead, Noah.
Sulfuric acid.
Excellent. Excellent. Prefix of hydro, ending of ec, word acid. Can I just say that a lot of names get slightly adjusted, often because of mistakes that were made. So Noah, this is perfect. We attach the prefix of hydro, we drop the ending of our anion and replace it not with I, but ic. So of course, sulfur, we become sulfic, but actually probably somebody mislabeled a bottle and it just got replicated. This is actually hydrosulfuric, which then we're violating the rules. I want us to always apply the rules, but just to know that sometimes mistakes were made and they just stuck. We're applying the rules. Okay, very good, very good. Yes.
Would it be wrong if we put hydro?
I don't expect us to know those like weird exceptions that people have made. So if you want to remember that, that is totally fine. Okay, so now let's go then to our oxy acids. All right. Oxy acids have more than 2 elements, and they usually have oxygen in them, hence oxy acid. Remember, we look to the polyatomic ions ending. No prefix of hydro. We just go to the polyatomic ion. Max, Cr2O7 with a -2 charge. What is the name of that?
So it would be, wait, so when you say -2 charge, does that mean the whole thing has a -2 charge?
It does. Cr2O7 travels with a -2 charge if it's the polyatomic ion I'm asking for.
So it would be dichromate.
Mm-hmm. All right. What we do is we change the ending of ate to ic. Remember, I told you that little saying that a student of mine years ago said, if you ate an acid, it would be icky. Oh, if that helps us remember it, great. Ate to ic, ate to ic. So dichromate becomes dichromic acid. So if it's an oxy acid, no prefix of hydro. It's wrong if you put the prefix of hydro. You look to the polyatomic ion ending, ate changes to ic, ite would change to us. So 3, SO3, Anna, with a -2 charge is what? What is SO3 with a -2?
It's
It is. Which one?
sulfite.
Fantastic. Sulfite. So Ella, then, if we're going to name H2SO3 that contains sulfite, it's an acid. The ending is ite. What would you name this?
Sulfus. Is that how you say it?
Yeah.
Acid.
Yes. Slam dunk. Slam dunk. Very good. Questions? Yes.
Wait, so this is like everything that we're doing on our quiz then, like basically?
No. This is half. The other half, but we'll look at that tomorrow, is if you're given the name, can we get the formula? Okay. So let's just focus on this. And once we have this down, this, easy peasy. Yes.
How do you know how many hydrogens there are just by looking at the words?
You don't. You don't. You don't. The only time the wording reveals your formula is if it's covalent. Phosphorus dioxide, trinitrogen heptaoxide. Okay, the others, no. The name does not reveal the formula. We'll have to do a little bit of work to get it. Okay. All right, can we? Let's go to page 11, please. Page 11. All right. If we just look at the first 10, just the first 10, Troy, can you choose one that you think, oh, I might not be able to get that so easily, the first 10? Number 9. All right. Can we just choose a couple, and can I share like the thinking I would do out loud? Oh, no, do you want to jump in and name it?
I was gonna say number 5 as well.
Okay, very good. We'll go over. Absolutely. And sorry, I apologize so much if I forget to. We know if a number is not a subscript, if it's a formula, it should be a subscript. All right. So the line of thinking I would go through is first, okay, look at your first element. And that first element, is it a metal, a non-metal, or hydrogen? Well, it's hydrogen. So I know it's an acid. So my next question, okay, is it binary or an oxy acid? It's only hydrogen with bromine. All right. I know then I need the prefix of hydro. Then the ending of ic on my anion. And then the word acid. So the first element diagnoses the type of compound. And then we just have to know the questions to ask ourselves from there. Okay, so Noah, you said number 5. Nickel, a metal. Is it a metal that I always know the charge of? No. So I need to go into the formula. All right, nickel is paired with 2 perchlorates. Perchlorate is a -1. I have 2 of them, so collectively that delivers a -2. You don't have to do any of this work, but I encourage you if it helps you. 2 perchlorates gives a total negative charge of -2. So what will this one nickel be? Well, it must be a +2. So the name of this is nickel 2 perchlorate. Ella, is there, looking at the whole list, is there another one that it would be good to do together?
Like 1 through 10 or
No, the whole list, 30. All 30 are fair game.
trying to find a transition better.
Sure, take your time, no pressure. Good, 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 good. All right. So, FeS, okay, I do not know the charge of iron. So I look to what it's paired with. It's bonded with sulfur. I look, I know sulfur is going to show a -2 charge. There's only 1 sulfur. I only have 1 iron. So to be a neutral compound, that 1 iron must be showing a +2 as well. And so This is iron 2 sulfide. And the ending of I, because it's not a polyatomic ion, it's monoatomic, I replace the ending with I. Yes.
Just a quick question. How are you finding the charges like looking on the periodic table?
All right. So we know that metals can only and will only form cations. Group 1, Max reminded us, is
+1,
excellent. Group 2,
+2,
silver.
+3.
Okay, I'll show you a really, really nice way to remember. Okay, +1, +2, +3 for aluminum and gallium. Those are in groups that stick up from the periodic table. Somewhere along the line, someone nicknamed those main group metals, even though they're not all of these, or these are, they always show the same charge, okay? So if we start and ignore these for a moment. So 1, 2, 3, aluminum and gallium, 3. And then check it out. Silver, +1 always. Zinc and cadmium +2 always. And then aluminum gallium +3. So look how nice that is. 1, 2, 3, 1, 2, 3. Yeah?
Yeah.
Okay. Noble gases, Abby, we know don't give or take because they already have their octet. Halogens, they're nonmetals. And if given the choice, nonmetals will gain. Okay, and these then have 7 valence electrons. They're -1, -2, -3, -4, -5.
Okay.
Okay?
I'm just thinking of the electron levels, like how they go 1, 2, 2, 3, 4, 5, 6, 7, 8.
As far as valence electrons?
Yeah, I was like flipping them.
Oh, that's so easy to do. So easy to do. And they form that charge because of the number of valence electrons. Yeah. Okay. Sam, is there another one here that you think would be good to do together? Great. Okay. So, do we trust the charge of cadmium? Yeah, always, always, always. So we don't have to do anything with our formula to determine the charge. And so this will simply be cadmium and NO3 - 1 is nitrate. Okay. All right. Abby, even or odd? Odd. All right. So can I ask us, besides the ones that we did, can you now answer the odd? Okay, answer the odd, and I'll be around to address any specific questions you might have. If you want to check in with your neighbor, you definitely can. And let's see where we are in about, 7 or 8 minutes. when the it and the us. Okay. But if it's not, then I.
Wait, so that includes dry.
But you need to like. It wouldn't because compounding those are going to repel. So the only time with the polyatomic ions that we work with, when you have two polyatomic ions in a compound. Mhm. If I ask you, can you go to the station? Answer me a metal or a non. That really applies that designation when we're talking about the physical property of conductivity. Otherwise, okay, so it's a metal. So the next question I would ask is, okay, it will show based upon splits on the periodic table. Two, aluminum and gallium, sulfuric acid. Correct.
I tried. Sounds wrong. Yeah. Yes. I got hexoxide.
Determine its charge. Show the charge in the
When it's, oh, but it's, antimony, but it was only one in the first one.
correct.
And then, nitrogen is tri. But if there's one in the second, that's, could be wrong.
Correct. Yep. You're right. Okay, so Great question, great question.
For this?
Can you continue to work? If you're already done, you need to be patient. Can you continue to work? We'll share the answers in 2 minutes. Address questions, and then you'll get a break. Okay? All right. You recognize this? Because if you have a method, it's gonna. Okay. All right. Then you send the bridges. Yeah. So for example, and so the prefix we use for one is
I was like,
for two
I
is
just
five,
got one credit.
is
I was like,
four.
what was I rating?
Perfect, yeah, and so.
And I was like, I'm gonna watch it. I'm gonna watch it.
And so.
Watch it.
We should actually.
Yeah. I was in the 9th grade.
We had irons, remember, I got
right now, like, I'm not in the middle school. Like, yesterday, I was like,
and then the word.
it was like the word drop against my lip.
But this is the phosphorus and ion.
Through, I skipped through.
But
the
we drop
various- I did
ion,
it,
but we have to show how many there
I
are.
listened to
So
Henry
drop
answers.
phosphorus.
And that's it, like, I don't think. Yeah, I got the story on.
And so.
I'm not done.
Oh my God, oxygen.
My
is
11-year-old.
your hand.
He specified 11.
So we would drop the ending.
He went on.
Green does say phosphorus.
I was like, of course I'm giving him. Why would I not?
Did that address my question?
Wait,
Yeah.
I'm so
So,
confused.
because I'm an 11-year-old, I'm giving you guys time classes.
Which one? Which one?
And then he's like,
Okay.
yeah.
So if it's H3N,
Wait, what?
that,
For the
it's like
first
one
one,
acid,
there's a covalent hydrogen put bond in front of the first one.
Yeah,
But if it's like.
Yes.
then why is it
Nice.
NH3?
Hold on.
Because H3N and NH3 are the exact same.
Cobalt
thing-
two, five,
Those are
something.
different things.
Wait, I got-
You know
Oh,
that
wait,
it's-
it's not copper. Oh, no, I think you're right. I was like, copper C. Yeah.
But,
Okay.
so H3N
It's
would
like
be
the
that.
one, it's the last.
But
one.
NH3 would
Second to
not.
last one.
Wait, what?
It has to start with H. It doesn't matter. H is in the formula. The first one has to be H for it to be the answer. No, it's just the ones that start with H.
So the trihydride.
I feel like you're gonna.
Trihydride.
So
Hydride.
it's.
Oh,
I feel like you're getting more lax.
Okay, let me.
Okay, so if it would be just HCl, prefix of hydrogen. But as soon as it's hydrogen, there's no prefix of hydrogen.
Yeah.
Oh, yeah.
This is
Okay.
confusing.
Okay.
And then
It
what
was
else
like-
would be right? This one's.
Facts, yeah.
Okay, I'm ready.
Oh, wait, this is an acid.
Right. So you just name your two polycarbonate.
For what?
Okay, then, so then for this, you just.
Okay, so that's nitrite.
Yeah.
Or nitrite.
That's nitrogen. Right.
Right.
Well, I have physical therapy on Thursday.
And that's why it-
So then tomorrow, I don't have a ride, so I have to wait for my parents to.
I'll
So
address your
be there
questions.
for everybody.
Okay.
Yeah.
And give you confidence with that, I promise.
Okay.
Right.
Yeah, I already told her this one.
Right.
So this one. You can also take a bus. So you can actually take the bus.
The only time
Okay,
it's ever changed any polyatomic ion naming is
I
when
was
it's an
thinking
acid.
it was water.
Is that an acid?
Huh?
Like, if
Doesn't
it's
matter.
not
Four.
because it started at 3. So we only had to start like 10 minutes.
Correct.
We should start.
So just name it.
Like, I don't like it. Sometimes for soccer, they would make us like, wait, we'll do that.
Wait, is that
I'm like 9th grade.
You got it.
Wait for the bus,
Yeah.
and then no bus would show up. And then so they were like, maybe to one. Yeah.
Troy, I encourage your question, and I want to give you certainty. So can we go through the answers? Maddie had asked an incredible question that I want us all to benefit from, as well as Troy. So please don't hesitate. And please, I hope that you guys know you can trust the chemistry we do is like legit for real chemistry. So please, I promise that I'm not, making this up or like, all right. Number 1 would be sulfuric acid. It is fine if you called it sulfic. That's one that someone mislabeled somewhere along the line. Okay. Number 3 would be nitrogen trihydride. Okay, we did 5. 7, tetraphosphorus oxide. We did 9. 11 would be antimony. 5, that would just be a V, yeah, with a cap and a base. Chloride, antimony 5 chloride. 13 is hypochlorous acid. Hypo, not hydro, hypo. Yes, ma'am.
Why would antimony have a 5 after?
Okay. So, in our periodic table, our staircase, antimony metal, not one that we trust the charge on. And so when we go into the formula, SbCl5, I know that chlorine will deliver a -1 charge. And there are 5 of them. And so that will be a -5. Antimony, there's only 1 of them. And so it must be a +5. Okay, yes, ma'am.
So how do we know, other than the 2 columns and then the 5 that are like the little staircase, how do we know which one's not the plus?
Every other one. Yeah. And so we know always +1, always +2, always +3, 1 and 2.
And then we don't know any of the other ones.
Now, can I share that the more you learn about chemistry, the more familiar we'll get, because usually there's 2 different charges that they alternate between, and usually one of them we see more often. We are not expected to know that. Promise. Promise, promise, promise. Yes.
So why wouldn't it be hydrohypochlorous
Okay.
acid and not?
Wonderful question. Whenever it's hydrogen with only 1 other element, 3 parts to the name. Hydro, ending of ic, word acid. Okay. But here, it's hydrogen with a polyatomic ion. So no prefix of hydro. We go right to the polyatomic ion. And here, ClO-1 is hypochlorite. All I did was change the ending of ite to us. And I know, like, that's why I wanted to just say again and again, it's not hydro, it's hypo. Because it's the original polyatomic ion name. So no hydro because it's not a binary acid. Yes.
Number 11.
Uh-huh.
Why wouldn't it be antimony tetrachloride?
Because it's not covalent.
Oh, so you only use those prefixes if it's covalent?
Correct.
Okay.
Correct. Yep. And so that's perfect then, Max, to go into 15. Sulfur, non-metal. So I use my prefixes. Sulfur dioxide. Okay. All right. Questions on the odd in the left column? Yes, sir.
Why wouldn't 3 be an acid?
Okay. We will learn that acids are hydrogen donors. That's how we as inorganic chemists define acids. Now, for now, I'm saying acids begin with a hydrogen ion. That's how we tell it's an acid. Okay. How we write them is that way because when they react, for example, with water, they give away the hydrogen ion. So this will be to come, information to come. And it's really this that has all the properties of being an acid. Okay. So we write it this way because this bond is easily broken, quote unquote, because we're going to form this. Okay. But this does not. NH3 is actually a base. It does not give away the hydrogen ion. So we write it so that we don't get confused. Okay. Yeah. So it's a little frustrating here. You'll never have to know this because Troy, actually here, hydrogen is the +1, but we don't write it that way because we don't want to confuse it as an acid. Okay. So even though a lot of these compounds contain hydrogen, for example, here, that hydrogen is not going to be donated in a chemical reaction. That's why it's not classified as an acid. Okay. In our kind of chemistry, we write it first. Okay. Or like in 26, okay, this is an acid, but it's only this hydrogen that will be donated, not these. That's why we write it that way. Okay. Yeah, you're welcome. You're welcome. Sorry that it's not just if it contains hydrogen. No. Did that address what you needed? Okay. Maddie, we're going to get to yours. Any other questions on the left column? So then the right column, 17 would be carbonic acid. Okay, no prefix of hydro because it's not just hydrogen with one other element. This is carbon 8 changes to ic. 19, bravo for seeing 2 polyatomic ions. The only time we adjust polyatomic ion names is if it's an acid with hydrogen, yeah? So this is simply ammonium nitrate. Maddie asked an excellent question. Do you mind sharing what you asked?
Just if there would be any other ones that had two polyatomic ions within ammonium.
So what if, and I think, did you say like, what if we had, maybe perchlorate and nitrate bonded or phosphate and perchlorate? So the answer is
No,
because
they're all negative.
can we ever have a compound made of 2 negatives? No, they're going to repel. So no. So the only time for what we have to learn, we'll have a compound with 2 polyatomic ions is if it begins with ammonium. So we just need to be a little bit on the lookout because we could just judge and say, oh, it begins with nitrogen. It's a non-metal. So therefore covalent. Just be careful. Okay, 21 is potassium nitrite. 23 is copper 2 fluoride. 25, lithium selenide. 27 would be cobalt 2 thiosulfate. And 29 is aluminic or us. ALO2 is aluminate. ALO2 with a -1, aluminate. 8 goes to X, so aluminic acid. Questions on any on the right, in the right column? Okay, I still open the floor to any of your, yes, Tyler.
So for K on O2, why wouldn't the
Great question. The only time we ever alter any of these endings is if they're paired with hydrogen in an acid. This is an ionic compound. So I just name my pieces. I don't have to show the charge of potassium. And I just name this as it is, okay? But if it began with hydrogen, then I have to change its name. All right, so I owe you 4 minutes. If you need to go to your locker, we'll take a pass then. Otherwise, get out of your seat and go to the restroom, get a drink. All right, 45. Yes, Tyler.
So for XCF4,
Uh-huh.
would xenon have like the Roman numeral 4 in parentheses for that? Because
Is xenon, okay. Metal, non-metal, hydrogen.
metal,
Yeah. So my brain would go toward, oh, I need prefixes. I have to do anything with charge.
so charge is just whenever it's a non-metal.
When it's a transition metal that we don't trust the charge of, then we have to get its charge from the formula.
And then that's where you put the Roman numeral.
Correct.
Okay.
Yeah.
So then you would know AG, CD, ZN.
Correct.
Okay.
Correct. Yeah.
Thank you.
You're welcome.
No, I actually like there were a few tests that I was just like, I can just do this right now. Just that it was core for like I did and I got like that was like and I'm so mad for me. I the only other shots that I needed. Oh my god, that was for one week. I did the best one I realized. It's tiny. I was like 3 or 4 times.
All right. Any other concerns that are on your mind about naming? I'll ask you to do a little bit of practice tonight, and tomorrow we'll keep practicing. So are there any last issues? All right. So our chapter is divided into 3 main topics: formula writing, naming compounds, and then formula analysis. And that is a lot of what chemists do in the lab situation. You don't have to turn to it. We, in Honors Chem, in this unit, when we say formula analysis, we mean these 3 types of calculations. And so, to get us started, if we would turn ourselves to page 22. Now, as you are working your way there, I will ask us to do some formula naming tonight. But you know that I always like to give us additional support if we feel like we need it. So I'm just showing you page 18. Page 18, here are 50 different formulas and then up to 100, but I cross them out because those are a little bit of old-fashioned ways of naming. And the next couple of pages, I've given you the answers. And so there's some more practice if you would like that beyond what we'll do in class and for homework. All right, percent composition. Could I ask you yourselves to just read what I have as the definition, of course, of percent and percent composition? We will entertain many different kinds of percent composition scenarios this year in Chem. When we are being asked for the percent composition of a formula, it is, as it reads here, a percent composition is always part compared to the whole. Part compared to the whole, but what is the part and what is the whole in the scenario that you're looking at? Now, we are making these percentages. So we could come up with the formula ourselves, actually. Percent composition, part compared to the whole. Okay. Usually it's a mass ratio, which we know mass will be in grains. All right, from the definition that you read, Troy, what is the formula that we'll be applying to find percent composition?
Would it be mass of one element on top over the mass of the total compound?
Oh my gosh. So fantastic. So fantastic. So we could say the percent composition is the mass contribution of the element divided by the mass of the compound. And so we're talking about the total mass a single element brings compared to the mass of the entire compound. But we're just missing one thing, sir. To make it a percent? What are we missing from the formula? Yeah, exactly. And remember, the 100 does not impact our significant figures. All right. Could you give us an example formula that is something common, or from the worksheet that we were looking at, can you give us a formula, a chemical formula? Let's deliver the formula. Can you give me an example of a formula of a compound? Any compound. And I know whenever I ask like anything, that's kind of like, do you want to give me ionic? Do you want to give me covalent? Do you want to give me an acid? I'm just asking for an example formula, like NaCl, H2O, CO2.
Oh, okay. H2O.
Sure. All right. If you would be asked to generate the percent composition of H2O, the percent composition of H2O, you will be delivering as many answers as there are separate elements in your formula. Okay. If you're just asked, what is the percent composition of water? Then you'll deliver the percent of hydrogen and the percent of oxygen. Unless it specifically says, what is the percent of hydrogen in water? What is the percent of oxygen in water? If you're just asked for percent comp, you deliver as many answers as there are separate elements. All right, we're doing some calculating. So we need our calculators. If you need to come forward and borrow one, please go ahead and do that. All right, we need mass information. Where do we get that? Best friend in this classroom. Periodic table. All right, what values are we pulling from? Yes. So for water. All right, we go to our amazing table. All right, hydrogen and oxygen. Well, what I need to know, right, is the mass contribution of hydrogen compared to the mass of the entire compound, just as Troy so fantastically said. And then for percent of oxygen, well, that will be the mass contribution of oxygen compared to the mass of the whole compound. How do I get my numbers? I know it's been a little while since chapter 3. We've done this. Go ahead, Noah. All right. Whenever you are pulling average atomic masses, how far do we report those? I'm sorry? Perfect. Absolutely perfect. Yep. And so what will you report 2 hydrogens to be? Very good. Do you think we need to show the work for the formula mass or we're good? Okay. 2.02. And then when you add that to your oxygen, what is the formula mass of the entire thing? You got it. And then oxygen will be 16 divided by the 18.02. Avi, could you get our answers, please, sir?
Then 0.21 for hydrogen.
All right.
And
Let's remind ourselves of Sig Fig rules. We're dividing.
11.3.
Excellent. Wait, are you sure 11.3? What did you say, sir? I'm so sorry. You said
11.2. At first I said 11.21. 11.2, sorry.
that's okay.
And then
We multiply by 100. The 100 does not limit our sig figs. That just got us to be a percent. So that's really an exact number. And it'll be percent. Well, percent of what? Hydrogen. Now, officially, it's the percent of hydrogen in water, but that's sufficient enough. And then 88.79% O. Okay. Remember Joseph Proust said what makes a compound is not where you get it or the sample size, it's the mass ratio. So if you have 1 drop of water, 5 liters of water, 11.2% of the mass is from hydrogen, 89% is from oxygen. Is there a quick way we could look at our answers and just kind of eyeball if we did it correctly? Caitlin?
If they like generally round up to 100, like because that would, if it was rounded to 10, it would be 88.8.
Perfect. Because we're rounding for significant figures for these values and then adjusting for sig figs, they'll very rarely add, if you find the percent of each element, to perfectly 100, but very close. Excellent, excellent. Could we look at 22? Now, if you are asked to find the percent comp of a formula, we need to go get our values from the periodic table. But for example, in problem 1, you're given values. So could I ask you to dig in, go ahead and set up how you would solve example 1 or problem 1 on this page, and then we'll check in with each other. By how much? Oh my gosh, it's totally fine. Because remember, you're rounding 100 for your numerator and then we're adjusting for sig figs for your answer. So that's what. 30 more seconds. First example we did, you were asked for the percent comp and we just knew the formula. We don't know the formula here. When you know the formula, we can go to the periodic table for our values. So we need to pull our values from the problem. Okay, you're told the mass of the compound and the elements that make it up. And so whenever we're just asked, what is the percent comp? Then I need as many answers as there are separate elements. I'm given the mass of the whole compound. So that is my denominator for each of these. Oh, 89, sorry. So continuing to read, it says, oh, wait. I'm so sorry. I read too fast and started to, I'm so sorry. Experimental procedure showed that 23.11 grams was carbon. So in this mass, 23.11 grams is carbon and 63.42 grams is oxygen. Well, shoot, Tyler, I also have hydrogen there. How do I find its mass?
You add up carbon and oxygen, then you subtract that from the total mass.
Excellent. So if this is everything that's in my compound, and this is the mass of all of these, and they're telling me in this, that's how many grams of oxygen, that's how many grams of carbon, I need to add and then subtract from that. And excellent, excellent, excellent. What it is 3.19. And so then doing all of your math, adjusting for sig figs, we should get 25.76% of carbon. We should get 70.69% oxygen, and then 3.56% hydrogen. Sorry, Miss Oscar, did that address?
So the whole compound, so you know how you put like 4 carbon, you put C and oxygen, so at the end of the grams, for the whole compound on like the bottom, you wouldn't put anything because it's a compound?
Well, I could put compound because I don't know my formula. I don't know what that is. So really, I should put compound on the bottom. And I don't just want to write C because that looks like carbon then. So I should put compound. That's why it's wonderful if we know the formula, we can identify it. Okay, thank you for that. Thank you. Any other concerns? Yes.
So if we just have like, if we just put comp, then would it be, or if we did, would that be what we need to do? So if we didn't, it would be wrong. Or like not wrong, but.
I know what I want, absolutely 1,000,000%, is the mass and what element. So we need that. As long as we're putting gram, I'm okay with that. What would be best is if we could put the formula, or it would be best. But if we don't know the formula, I'm okay if we just put gram. But that we need this. Yeah, for sure. And we absolutely need to identify percent of what. Tyler, did that address what you need? Okay, questions? So, are we fans of gum? Gum fans? Not so much gum fans? No, Tyler. Sorry. Not a surprise. Someday, Tyler. Someday. I'll get it right. Someday, someday. Anna, do you have a favorite type of gum? Any type of gum will do?
Yeah.
Excellent. Excellent. Let's, Caitlin, favorite type of gum? Any type will do? Troy, are you more a fruit flavor kind of gum fan or mint? Mint. All right. Or do you like those apple pie flavored or mint chocolate chip? That's kind of minty. I'm sorry.
I've never heard of that. Where can you find that?
Is that still, I don't know. I think a couple years ago, there were definitely more types of gum out there. I don't know. Did Trident try for a while to like give all these like really unique flavors, like apple pie? I think there was like,
They have like Starburst gum.
yes. But yeah, it's a little hard to find. I think like Orbit seems to be a dominant brand, or maybe just around here, maybe because they cooperate with Target and Giant Eagle. I have no idea. Usually I'm just standing in the grocery line, and that's why I look at all the gum and everything else. Sorry, not that I'm necessarily. I like mint as well. Avi, your favorite type of gum?
Probably mint.
All right. Well, I hope that I'll appeal. I thought we'd have time today, so this will have to wait until tomorrow. So I do have mint, but I also found some Hubba Bubba. So here we go. Yeah, strawberry watermelon and blue raspberry. Thought that would just be a little appealing for us. Okay, so we're going to do something. You will be able to enjoy a piece of gum tomorrow. We're going to experiment a little bit. Okay. So we'll pause on the calculations. The lab activity with gum will come tomorrow. What I will ask us to do for our homework will be the even on page 11. The even. All right. Do we want to get started on homework, or I can ask us a question? Start on homework. Does anyone want to share something super fun that you did over break? Yes, Noah. Oh, I think probably all of us are in that category. I don't know, did anyone not get a cold or something else? Oh, yay. Oh, yay. I'm so happy for you. Same with my whole family. Yeah. Oh, so the rest, but you were good. Very good. Anybody else? Super fantastic. Yes.
My sister held a housewarming party.
Oh, that's really exciting. Oh, new house. That's really exciting. Max,
I got to sleep.
see, isn't that just a wonderful thing? I saw the Spider-Man movie. Oh, 2 thumbs up. Not to spoil it for anybody. Yeah. And I'm an old person. I thought it was excellent. Yeah, I thought it was really, really good.